many of which can bind non-specifically to antigens. C3d can bind to an antigen and can then be bound by CD21 on a B cell. So if a B cell has a B cell receptor that's bound to an antigen, and it also has a CD21 that's bound to an antigen, then that will also initiate B cell activation. An activated B cell has one goal in mind: to differentiate into a plasma cell and secrete antibody. But there are 5 classes of antibodies that the plasma cell secretes. So initially, the B cell will differentiate into an IgM secreting plasma cell, because that's ready to go, since it's the basis for the B cell receptor. If, however, an activated CD4 positive T cell is present, it'll help the B cell to isotype or class switch, to change the isotype of the antibody it produces. Isotype switching requires a change in the DNA, and once the B cell switches its isotype, it can't go back to making IgM again. Now, B cells are one type of antigen-presenting cell, so they present antigen on an MHC class II molecule to a nearby CD4 positive T cell. If the T cell gets activated, it'll express the molecule CD40L on its cell surface, which binds to CD40 on the B cell surface. This causes the B cell to express cytokine receptors, and causes the T cell to secrete cytokines, instructing the B cell on the type of antibody to start producing. For example, if the T cell secretes interleukin 4 and interleukin 5, then the B cell will become an IgE secreting plasma cell. On the other hand, if the T cell secretes interferon gamma, then the B cell will become an IgE secreting plasma cell. Now, it turns out that every heavy chain locus, gamma, alpha, mu, epsilon, and delta, has 2 spare exons, one for membrane coding and one for secretion coding. So, for example, an IgM-expressing B cell, which hasn't undergone isotype switching and isn't a plasma cell, has a constant mu region expressed with membrane-bound exon. Once the B cell CD40 gets bound by the T cell CD40L, an enzyme called activation-induced deaminase, or AID, gets activated and breaks the intervening DNA, removing all of the constant region between the VDJ and the decided-on antibody. So, as an example, an IgG-secreting plasma cell would be left with a rearranged VDJ region, as well as the IgG region and the secretion-coding exon. Alternative splicing will allow the cell to still have some surface-bound IgG, and that allows the cell to get antigen stimulation while it produces IgG. At this point, the cell is a fully differentiated plasma cell. Now, it turns out that most mature B cells will live for about 6 months in the lymphatic system and then die, without ever being stimulated by an antigen. A sad and lonely existence. To replace the dying cells, there's a plentiful supply of fresh, new mature B cells coming out of the bone marrow. However, if the B cell does encounter an antigen and develops into a plasma cell, then it produces lots and lots and lots of antibody. Plasma cells live for about 6 weeks, and they don't divide. If you haven't cleared the antigen by the time the plasma cell dies, new B cells develop into plasma cells to take its place. Alright, as a quick recap. When B cells finish developing in the bone marrow, they use alternative splicing to co-express IgM and IgD on their surface. If a B cell finds its antigen, the antigen cross-links 2 B cell receptors, and that activates the B cell. If there's no T cell, it differentiates into an IgM-secreting plasma cell, also using the process of alternative splicing to allow for some of the IgM to be secreted and some to remain surface-bound. If there's a T cell nearby, the CD40-CD40L interaction combined with cytokines secreted by the T cell help the B cell class switch to produce IgG, IgE, IgA, or IgD. turning into tumor cells.
The immune response is highly specific for each invader, and that's because the cells of the adaptive immune response have receptors that can differentiate friendly bacteria from potentially deadly pathogens from their unique parts, called antigens. The key cells of the adaptive immune response are the lymphocytes, highly specific for each invader. And T cells develop cells of the adaptive immune response have receptors that can differentiate friendly bacteria from potentially deadly pathogens from their unique parts, called antigens. There are two types of T cells of the adaptive immune response based on the lymphocytes they express on their surface. The B and T cells. Helper T cells develop in the thymus, on their surface, where they undergo a process called VDJ rearrangement immune cells to generate a massively diverse set of T cell receptors, express CD8 on their surface, and their main function is to kill infected which are identified based on molecules they express on their surface. A T cell starts out naive, helper T cells, and then it gets CD4 on their surface, at which their main function is to support other immune cells.